Let's first start by implementing a loop using a flowchart, and then later we'll discuss it in pseudocode. But think about how you would draw the flowchart for a program that prints happy birthday 100 times, and go ahead and draw it out. I'll pause the video so you can think about it and draw out your flowchart. Okay, so let's take a look at it. And note that we don't need any new symbols for doing the loop. We've already got all the symbols that we need. And so here's what it should look like. While the counter, well, we set a counter equal to 0, and while the counter is less than 100, we're going to print happy birthday. And then we're going to increment the counter by 1. And then we're going to go back up and evaluate our statement and say, hey, is the counter less than 100? If so, do the same thing over and over again. So hopefully yours looks something similar, but this would be indicative of a while loop because we're going to check the condition first, and then we're going to execute the statements, increment it, and then check it again and keep going. You could also change your flowchart to do something that looks like this. And this would be indicative of a do while loop. Notice how we check the condition at the end of the statement blocks instead of at the top. So we're guaranteed to print happy birthday at least once. So basically we're going to use a loop statement if you need to do anything repeatedly. And the format generally looks like this. There are two main components, the loop heading, shown here, and the body, shown here. So how does this work? Well, while the loop condition is true, execute the statements and then jump back to the condition, like we've already seen with the pseudocode. And of course, there's some terminology that you have to know when you're working with loops. Iterations is the number of times that a loop repeats. And it's possible for a loop to repeat forever, and that's called an infinite loop. And I promise you that in your programming endeavors, you are going to run into a situation where you will mistakenly cause a loop to repeat over and over and over again because you didn't check something right. Again, it's something that every programmer has to deal with, and you will too. So how do we terminate a loop? Well, there's three main ways to terminate a loop. The first one is called a counter loop, and you've seen an example of this already with the happy birthday. And you use a counter variable to keep track of the number of iterations that you've gone through. You can also use a user query, and this is where you prompt the user to say, hey, do you want to continue? Hit Y to continue, and it'll do it again and again and again. Or finally, there's also what we call a sentinel value. And a sentinel value is similar to a counter, but it's a little bit different where it's going to check the user for input, but you use a number that's outside of the normal span of what you would enter. So for example, in this case, we're using -1, and that's something that's used quite often as the sentinel value. User queries and sentinel values are useful for when you don't know in advance the number of times that you must do something, where the counter variant is useful when you know, okay, I need to perform this process 100 times, or I need to perform this process based on a certain variable that holds the number of times that you're going to count. So you might ask the user, how many times do you want to repeat this? And the user will enter 100. And that 100 will get stored in the counter, and then you'll loop that 100 times because that's what the counter says to do. And of course, we also can have nested loops, and those are loops inside of other loops. An example would be an algorithm that finds the largest prime number from a list of user-entered numbers. So this is just an example here. You can look at it, but there's many examples of nested loops, sorting algorithms. There's all kinds of use cases for nested loops, and you're going to use them quite a bit in this course. So let's look at an example of a program or an algorithm that has two loops. Here's a quick little bit of pseudocode to process user input, have a user input a number, and check to see if that number is a prime number. And so what it does is it's going to say, okay, well, is the number greater than or equal to 0? And if so, we're going to start at the number 2, and we're going to assume it to be prime. And while the count is less than the number that we gave it, and prime equals yes, we're going to do this other loop. So you can see here we have 2 loops already. We have the outer while loop, which is going to execute while our number is greater than or equal to 0. And we also have our inner loop here, while the count is less than the number. And the count is what's going to get incremented. So we have a counter control, which is the control mechanism or the termination mechanism for this inner loop. So you can see here it's going to keep going. We also have a sentinel value down here at the bottom where it says enter a number or a negative to quit. So this is where you could enter -1. And that's going to go back up to the outer while loop and check to see if the number is greater than 0. And if it's not, it's going to exit the loop. So here you have an example with nested loops, you have a sentinel value, and you have a counter value all in one little algorithm.